All right, hello. This is the video lecture for section 3 of chapter 2. And so in this section we're gonna delve more deeply into our first model, the production possibilities curve, or the production possibilities frontier, abbreviated PPC or PPF. And we're going to look at the model this time, rather than in terms of individual behavior. We're going to think about the PPC as modeling a nation's choices, right? An entire economy's choices. So, like I mentioned in the last video, our model, PPC model, can be used to demonstrate the concepts of scarcity, choice, and trade-offs, really opportunity cost, at the individual level, like we saw in the last video with economics grades versus mathematics grades. But our model can also be used at a societal level, right? So thinking about the trade-offs that a society faces. So that's what we're going to look at in this section. All right, so here we've got a table of basically different possible combinations of the production of smartphones and tablets. And hopefully you can see the inverse relationship here, much like the grades PPC that we saw in the last video. But if we use all of our resources to produce only smartphones, we can produce 50 million smartphones per year. But that means, of course, that we won't be able to produce any tablets. Okay, so this would be akin to you spending all your time studying math, getting an A in math, but then getting an F in economics, right? Similar outcome. And then as we move down the table, we see that if we want to get more tablets, well, it comes at the cost of smartphones. We have to give up smartphones in order to get more tablets. Okay, so that's what we see here in this table. Now, if we were to graph this table, right, plot each of these points, these different combinations, plot them on a graph, and then connect the points with lines, we would have this curve here. So again, we in economics really like to use graphs because the information is basically the same, but we can obtain the information that the graph is trying to convey much more quickly than a table, right? You have to take some time and look at the numbers here and process the numbers and think about what's going on. Whereas here, it's much more obvious, very quick. Like almost as soon as you see it, you can see what the relationship is. It's an inverse relationship, a negatively sloped curve, and as you'll notice perhaps here is that this is not a straight line like our first PPC for grades. It's curved. It's bowed out, as we say sometimes. So. Now let's make sure we're understanding this graph here. So we've got tablets on the x-axis, number of tablets in millions per year. We've got number of smartphones per year in millions of smartphones on the y-axis. And we've got an inverse relationship, like I already mentioned. So if we want more tablets, we've got to give up some smartphones and vice versa. Now there's two other points labeled here, point S and point R. And we'll talk about what those points mean in terms of production here. So now recall our PPC is the curve itself, right? So production possibilities curve. So this again is sort of the frontier or the limitation of what we can produce. It's in terms of the resources that we have, right? So basically point R is not possible. We cannot possibly produce point R given the resources that we have. So in other words, point R is outside of the production possibilities curve. It's not possible. Whereas point S is within our production possibilities. It's inside of the production possibilities curve. But the problem with S is that it's actually inefficient. We're not fully utilizing all of our resources, so there is some inefficiency going on here with point S. We can, in other words, produce more of both smartphones and tablets without giving up anything. And so that's basically what point S represents here. So let's talk about some of the assumptions in our model. Let's make sure we understand the assumptions. Now, like I mentioned in a video from chapter 1, all models involve some set of assumptions. And the set of assumptions here is that resources are fully employed. Now that's along the curve, right? Point S, that is not, that's a point where resources are not fully utilized, okay? They are not fully employed at point S here. Only along the curve are resources fully utilized. So on the curve, so at point A, B, C, D, E, F, and G, at all those points on the curve, resources are being fully utilized. We're also assuming that production takes place over a specific period of time. So here it's in a year, right? So millions of devices per year. So our time frame is 1 year. Again, our resources are fixed in this time period, so resources are not changing. The resources we have allow us to make any of these combinations along the curve, and the resources are not changing. And we're also assuming that technology does not change over this time. I'll talk about this more later on, but technology doesn't mean what it usually means in common language for us. It's not only computers and electronics and those sorts of things, artificial intelligence, right? But it has a broader definition in economics. Technology in economics is the knowledge of how to produce something, right? So the knowledge or the process of producing things, that's technology. Okay, so we're assuming that that doesn't change, right? So again, technology is sort of society's pool of applied knowledge concerning how goods and services can be produced. So again, it's a little bit more broad of a definition than how we usually think of technology, right? So here's an international example about our PPC here. So the UN, the United Nations, recently adopted a list of production objectives for developing nations. These objectives were called Sustainable Development Goals, and they included additional amounts of drinking water and new dams and drainage systems. Now, according to some current estimates, there's an indication that these goals would require nations to reduce production of additional amounts of all other goods and services by 10%. So here we go. We see the trade-offs that a nation would face. If they want additional amounts of drinking water and new dams and drainage systems, they'd have to give up roughly 10% of everything else that they currently consume. So there you go, a real-life example of our PPC. Now, as I mentioned just a while ago, that point S here in our PPC graph, that's an inefficient point of production. Okay, so let's talk about what efficiency means in more detail. Now, there's a very specific type of efficiency called productive efficiency. And that's really what we're talking about in the context of our PPC model. But productive efficiency is being able to produce the maximum amount of output with given technology and resources. So again, those are our ceteris paribus assumptions. We're assuming that technology and resources are not changing, they're staying fixed. And so productive efficiency is what is the maximum output that can be obtained with the fixed level of technology and fixed level of resources. There is a more broad definition of efficiency. It's any situation in which a given output is produced at a minimum cost. So this is the concept of efficiency that we'll talk about in micro when we talk about the different types of firms that can exist in an economy. But in any case, those are actually basically the, you don't have to know this, but those are basically two sides of the same coin. It's called a dual problem. Those are two sides of the same coin. But in any case, those are our definitions of efficiency. So like I said, that point S in our PPC graph that we saw a few slides ago, that point S was an inefficient point. So any point that's inside of the production possibilities curve it implies that our resources are not being fully utilized, and so we're not generating the maximum possible output given resources and technology. So there's some level of inefficiency. Now, I mentioned the fact that our PPC for tablets and smartphones was bowed out. So we need to talk about what that means. Okay, so basically what it means is that the trade-off between smartphones and tablets is not constant. It's actually changing. Okay, so the slope of our PPC gives us the trade-off, and if our slope is not constant, like in a curved PPC that we saw with smartphones and tablets, it means that our trade-off is changing. The slope is changing, therefore the trade-off between smartphones and tablets is changing. And it's changing in a way that, let me actually go back to it real quick here. It's changing in a way such that if you want more tablets, okay, so let's suppose we start with 0 tablets. And we want to go from 0 tablets to 10 million tablets per year. Well, we only have to give up a very, very small amount of smartphones, right, going from point A to point B. We don't have to give up very many smartphones to go from 0 to 10 million tablets. But if we looked instead at the point F, right, where we have 50 million tablets, let's suppose we want to increase from 50 million tablets to 60 million tablets, right? So the increase in tablets is the same, right? 10 million tablets is the increase. But the difference here at point F is we have to give up a lot of smartphones in order to be able to increase the number of tablets by 10 million, as opposed to point A, where we only had to give up very, very few smartphones. So in both cases, the change in tablets was 10 million, but at point A, we only had to give up very few smartphones. In fact, we only had to give up 2 million smartphones, right? You see the difference there between A and B. We only had to give up 2 million smartphones to get 10 million tablets when we started at point A. But at point F, to get 10 million more tablets, we have to give up 22.5 million smartphones. Okay? So that curvature is basically showing us that the opportunity cost is increasing. So this is what we call the law of increasing additional cost, or sometimes called the law of increasing opportunity cost. So basically this means that as society tries to produce more of a good, the opportunity cost of additional units of that good generally increases, right? So we have to give up more and more smartphones to get an extra 10 million tablets, for example. And this, again, is what causes the bowed shape of the PPC, okay? There it is illustrated again, right? So starting from A, going to B, that's an increase of 10 million tablets, but we don't have to give up very many smartphones. But every time we increase production of tablets by 10 million, we have to give up more and more and more smartphones. So that's the law of increasing additional cost, or law of increasing opportunity cost. And the opportunity cost for 10 million tablets is biggest going from point F to point G, right? We've got to give up 22.5 million smartphones. Really big. All right, and another reason, basically the underlying reason for this bowed shape is that resources are not perfectly adaptable for alternative uses. So in general, the more specialized the resources are, the more bowed out the production possibilities curve is, right? So basically what we assumed in the grade PPC that was linear, right, not bowed out, we were basically assuming there that your study time is perfectly adaptable for economics and math, right? So an extra hour of study time in math would increase your grade by the same amount as it would spending that extra hour of study time on economics, right? So perfectly adaptable in that example. But here in this example, since it's a bowed PPC, these resources are not perfectly adaptable. And we'll probably see that more clearly when we think about some other examples using this model in the next couple of sections here. But this concludes section 3 of chapter 2. I'll see you in the next video for section 4.